Is the mic on? Seems to be. Good. Hey everybody. It's been a really great day so far. I've learned a ton of new things. And during the next 25 minutes, I aim to teach each and every one of you at least one practical thing that you can bring back to your work next week and start using it on the first day. I will be going through quite a couple of different things, but don't think that you need to pick all of them up. If you can pick up one new thing and actually start using it, then we've succeeded today. So let's start with a little bit of audience participation. So raise your hand if you've ever written a bug. So everybody, you're a brilliant audience. You've fulfilled your role as being the right audience for this talk. And now it's my turn to do the same. So I'm Juhis. I come from across the pond, from Turku, Finland. And I've been building developer communities and teaching people programming for the past 10 plus years. And one of the things I've noticed is that no matter if it's a student or a junior just starting their journey, or a seasoned veteran, an experienced developer, the debugging skills have been alarmingly missing. A couple of years ago I started writing and talking and teaching how to do debugging in a way that it's less stressful and more fun to do. My talk today has two parts. The first one will focus on the fundamentals, the processes, the mindset, things that you can apply to every and any debugging situation. No matter what the language, no matter what the project, no matter if you even know the language or the project, these are the steps that you should follow because they will make it so much more effective and so much more productive to debug your code. And then on the second half, we're going to talk about Python-specific tools and techniques, starting with the simpler ones, going up in complexity and how advanced they are. So I hope that everybody finds themselves somewhere on that line. And mastering both sides of these is really crucial for becoming good at debugging. Because if you know all the mindset, all the processes, but you don't know the tools, you will eventually come up with the solution, but it will be slow, it will be painful, and it will be really stressful. On the other hand, if you only know the tools, you're just randomly trying out things, and that's not fun either. So let's start with the fundamentals. When I talk about debugging, I like to frame it as all the things that you explore to figure out what's wrong. I really like this quote by Ryan because it leaves out related things that you could bring up, but I'm kind of intentionally leaving away. Things like writing tests. Whether you do that when you discover the bug or after you've implemented the fix, I don't care. Or, doing Jira tickets and managing the stuff. It's out of the question here. We're talking about you notice a problem in your code and you finish with knowing where the problem is. So also fixing it is something I'm not going to teach you today. You are much better at that than me. So let's start with the first thing. When you encounter a bug, especially if it's in production, just stop. Take a breath. Distance yourself from the situation. Because it can be stressful if something in production is going horribly wrong on Friday afternoon. But if you're rushing it, you're not getting anywhere. You're just making more bugs, even if you fix that one. Second one, and this is especially the one that I feel a lot of experienced, brilliant developers make the mistake. They have a problem in the code or in the software semi-educated guesses about your code by following a guideline and kind of putting your detective hat on and making sure that you do all the right things. It's going to save you so much time and so much effort. So I have this simple step-by-step kind of tutorial or process that you should follow. And this is iterative. So we do this multiple times within the debugging session. The first one and the most important one is make sure that the code that you're thinking about is actually being run. There's been so many cases for me and others that maybe you have production open and then you run it and you encounter the bug and then you go to your code and you try to fix it and then you run it again on production and it's still broken. And now because you tried it already, you discount that possibility that that fix would have fixed it. On the other hand, you might be really confident that you know the path that the code flow takes, that it is hitting this endpoint and it is running this function. But I've seen so many times, myself and others, be mistaken by the assumptions that we make. There's a really great meme about this by Jen on Twitter a couple of years ago. That it really exemplifies the issue that we can have. We put a breakpoint somewhere and then it's never hit. And now we put it there because we thought it's gonna be hit. So always start by making sure that whatever you think part of the code is running, make sure that it actually does. The second one is to make sure that you can replicate the bug. So once you've made some kind of insurances, we'll talk about the techniques, and then you run the code, make sure that you can run it and repeat the bug reliably. Because otherwise you won't know if any of your fixes are doing anything, if you can't repeat and reproduce the bug. And the third step, which is kind of the kind of main content I feel of debugging, is that every step of the way, examine the state, look at the variables, look at the stack trace. Is it doing what you think it should be doing? Take a look at the values, the flow, the branches. Are things happening in the correct order? And make no assumptions. Assumptions are the root of all bad things. We make them because we're human, and it's okay. But if you put these kind of checklists and processes in place, you kind of remove your human error from the equation, and you trust the system. And of course, you can talk to the ducks. So there's this thing called rubber duck debugging, and just in case somebody's not familiar with it, it is this kind of half-day inside joke in the industry, but it's also super efficient way of debugging. It works in a way that you have a rubber duck. I'm today joined by an avocado, which is playing the role of a duck. You ask the question, you explain the bug to it. Then you describe what you've tried and tell it what you think the issue could be. And so many times before the duck has time to answer, you figured it out. And the reason it works is that the human brain is so good at convincing us it knows something and skipping over detail. So rubber ducks work because it forces us to say everything out loud. And that's usually when we notice, oh, by the way, this is missing something, or it shouldn't do that. And then you go and fix it. So that's the first part of the kind of non-technical stuff. Let's move on to Python, since we are at PyCon. There are plenty of different tools, open source libraries. Probably if we would poll and then you run it. And you get an output like this. So it will print out all the lines in that annotated function that it runs. And whenever the state changes, it will print out the new state. So it's really handy in situations like this, where we have the number that we get as an argument, the bits list, number, remainder, they're changing all the time. So you don't need to write a single print statement, and you get a lot out of it. I find it helpful for small functions, because this is just the first 20 lines that I was able to fit into the screen. But when you run it with that function, it gets long, and it's sometimes difficult to read. But it gives you this overview, especially if there's a lot of looping happening. So then let's talk about debuggers. How many of you have ever used debugger with Python? Awesome, most of you. So let's start with the basics for those who are not yet familiar with. So debugger is a program that it suspends the execution of the program or of the script at the moment it's invoked. And then it inserts you right in at that moment with that state. And it lets you execute the code step by step, run other Python code. It lets you take a look at the state. And compared to printing or snooping, you just need to put it in once. And then you control the execution of the program. So you can spend as much as time you need inside the debugger to figure these things out. To start the debugger, you add this breakpoint call into your code. For example, like this one. This is a function from one of my projects. It makes an HTTP request. It gets some HTML. It parses that with beautiful soup. And then it halts or suspends. And then you jump into this REPL called the Python debugger. And you can run, for example, the names of the variables to examine the state. We have the collection name. That was one of the, I think it was the argument. We get the record status. Okay, it's 200, everything looks good. But compared to regular REPL, you also get these debugger statements, like args, that prints all the function arguments. It's really handy to know if the problem happened before this function was called, or after the breakpoint. You can run things like next and continue and quit, and there's a bunch of others. You can find them on the docs that let you take a look at the code, take a look at the state of the program. And we can control these debuggers with an environment value called Python breakpoint. We can set it to any debugger that we want by setting Python breakpoint to the setTrace function of a debugger we've installed. We can also set it to 0, which means that it ignores all the breakpoints. This can be handy for production server, so that if by some accident you end up merging in code with breakpoint, it won't stop your web server or whatever it's running, or your ML models being run, and then after 40 hours, it just stops for a breakpoint. And if you either unset it or set it to empty string, it will default to the default Python debugger. So the second debugger that I want to show is IPython debugger. It's very similar to the PDB, the Python debugger. But for example, if you're familiar with IPython, maybe you use it as a REPL, it might be fun to use the PDB as well to get the similar kind of environment. But both of these have, in my mind, kind of a glaring issue. They're good for simple stuff, but because you only see that one line at a time, you either need to run some list commands to see where in code you are, or jump between the code and the debugger, or maybe you need to be constantly checking, oh, what was the value? So the next one is called PUBDB, and you set it up similarly than the execute a couple of lines. We get to line 18. We can see on the top right that there's now much more of content, a lot of more local variables. And it's nice that you don't need to print them out every time in the debugger or with the print statement. You can just look at them. But not everybody likes terminal UIs, especially this kind of multi-pane where you need to jump between, back and forth. So there's also WebPDB that works pretty much the same, but instead of starting a terminal UI, it starts a local server. And when you go to it, it looks similar. You have your code, globals, locals, and the debugger. But I can do you one more, one better than all the 4 recent ones. There's this debugger called Bird's Eye, and you import it, you annotate the function, and then you run it. And instead of stopping at any given point, it records what happens. And then it gives you this web UI, where you can see similar things than the other debuggers. But if you look at the bottom, you can see the code and a lot of rectangles. And I think that's where the beauty of Bird's Eye really is. Because you can select any rectangle, not just the end result of the variable, but any intermediate step. And then you drag them at the bottom. So whenever they change, you can see it right here. So if the end result is wrong, you can go kind of step by step back and look at the different intermediates to see what went wrong. And because it records, you can go through the different loop iterations one by one and see where the mistake happened if you came to the conclusion that it ends with inside the loop is the problem. Couple of really quick fire Django tips. You can register a filter with the breakpoint, and then when you put something in your templates, it will trigger the breakpoint in your Django console, which is really handy for some more complex objects. Django toolbar is probably familiar with most of the people who use Django. It gives you this developer environment on the front end where you can see the request SQL queries. And there's a VS Code extension called Colo, which does similar things, a little bit more, directly in your editor. So you can see the response from a request. You can see the SQL queries, and so on. Let's recap. Stop and breathe. Take a moment. Don't rush. Don't guess. Be detective. Go step by step. Figure things out. If all things fail, talk to dogs. Printing is the best debugging tool. Learn how to use it well. Check out Snoop. It has a couple of other different modules as well inside. And learn how to use debuggers. Talk to your colleagues. Ask which ones they're using. Test out different ones to find out which is best for you. And last but not least, I run a monthly newsletter about debugging for developers like you. It's not just Python, it's across all the different technologies. And I aim to show people different ways to debug, different ways to think about it. You can subscribe email, RSS feed, you can read it on web. And in the end, the slides are available if you want to check something out. And good luck with your bugs. Thank you.
Questions? Questions?
Thank you very much for your talk and for saying to use print. I use it all the time when debugging. Sometimes I leave it there because I forget. And on one occasion, I realized that my colleagues 5 years later were afraid of removing my printouts in the code. I wanted to comment on something you said during the theoretical part, which is you say don't guess, don't make assumptions. It makes a lot of sense, of course, but wouldn't the better advice be check your assumptions? Because sometimes the guesses you make can point you in a direction. Most of the time, at least in my experience, it's useless, but at least if you go there and check, then you'll have more information about the state of your application.
That's a very good point, and you're exactly right. If you make assumptions, do check those assumptions. What I like to do to avoid the situation that the assumption is incorrect is to follow the breadcrumbs. So if I'm doing like a Django app, and there's something wrong in the front end, I would look at which endpoint are the requests being made, and then I move backwards and kind of I try